Okay guys, let's take a look at today's lesson. So we're going to be looking at arithmetic sequences in series. So we have two specialty kinds of sequences. Okay, two specialty kinds, arithmetic and geometric, which really, to be honest, are kind of a small portion of all the possible sequences in series, right? Just two special kinds. We like them because they provide formulas for us that we know we can learn and know. So they're kind of handy, but I want us to understand that these are just small little subsets of all sequences in series, the arithmetic and geometric. So we're working with arithmetic today. If you recall from last year, an arithmetic sequence is one that has a common difference. You know, like you're adding or subtracting the same number over and over again. You know, maybe you add 5 over and over again, or maybe you subtract 1. You know, that is a arithmetic sequence, and that's what we're going to focus on today. So the formulas in this unit actually are formulas that you would need to memorize. I'm not going to give you any of the formulas. Let me explain why. We actually use these formulas in calculus, and for this formula in particular, I've seen questions on the ACT and the SAT test where if you knew that formula, you could get the answer much faster. Now, could you get the answer to one of those ACT or SAT questions without the formula? Yes, it would just take you longer. So it's handy in a lot of different instances, so we will need to memorize them. Okay. Now, the reason we didn't memorize the rotating conics formula is I know you're going to be upset. But there are no rotating conics on ACT or SAT, and we really don't rotate conics in Cal 1 or Cal 2. So really no need for you to memorize those formulas since that was a single use and we're not going to use them again, you know, for years. But there's a reason to memorize these because these are helpful. These are helpful formulas. All right, so this is our formula for an arithmetic sequence, and if you recall, A is my first term and D is my common difference. Okay, that's a formula. If the end result of the question is the formula, I would really need you to distribute and combine like terms to get it into, you know, a pretty form. But if you're just using it for something, you don't need to do that. Okay, but if this is my answer, I would need you to distribute the D, combine like terms. Then we have two different formulas for summing an arithmetic sequence. This one, I'm going to start with this one actually. This one is the most simple, really kind of, I think it's a cool formula. Let's talk about it. An arithmetic sequence is just so, like, just kind of calm, right? Just adding to all the time. There's no crazy things going on with arithmetic sequences. It's very regular and calm. What this is doing, if you think about this, the difference between each term is the same. So if I took my first and last term and averaged them, wouldn't I get like the average value of each term? I would get that. And then if I multiplied by how many terms there were, I could get the sum. I mean, it's a great formula. It makes perfect sense. I'm finding the average value of all the terms. I'm taking my first and last term and dividing by 2, and then I'm multiplying that by how many terms I have, and that will give me the sum. Okay, that formula, pretty easy, I think, to memorize, pretty straightforward. Very handy. This formula, the one above it, is a bit more complex. Let's talk about it. But it's quite handy in certain circumstances. And I have a problem, an example that I'll show you how this formula is handy. So this formula right here, I want you to notice how it has the nth term embedded inside of it. See that right there? So you can see, I know it's a 2a, but it's a plus n minus 1 times d. I mean, it's got this formula embedded inside of it, and it's for a reason. It's actually helpful in some instances, which I'll show you in an example. So maybe it's not too bad to memorize since it has a formula embedded inside of it that you already need to know, the nth term formula. You just have a 2 times a instead of a regular a, and then it's multiplied by n over 2. All right, so that's some formula. Could you get by not memorizing this formula? Yeah, you could probably get by and not memorize that formula. It just would take you longer. Okay, this formula is just going to help us solve a particular type of problem quicker than not having it. All right, so let's go to the exam. Are there any questions about the formulas? All right, let's go to the examples. So I have a few examples on the next page. Now, I welcome you to use a calculator for number crunching. I welcome you to do that. I do not have a problem with that. But, and I'll just tell you exactly the work that I need to see in order for you to get credit for the problem. I'm training you. You didn't know this, but you've been trained for years to prepare to do well on the AP test. You're like, what? Yes, even back in Algebra 1 and Geometry, Algebra 2, all the work that you're having to show is because you have to show work on the AP test to get credit. So it's all for a reason, not for torture or anything like that. It's all for a reason. So let's take a look at our first problem. We have the 11th term of an arithmetic sequence is 52, and the 19th term is 92. Find the 1000th term. Okay, I'm just going to write, I like to write my information up here. So I'm told the 11th term is 52, and the 19th term is 92. And I want to find the 1000th term. That just kind of helps me. Do you have to write that? No. This helps me know what's going on. So in order to find the 1000th term, I really don't want to, I only have the 19th term. If I find the common difference, do I really want to add that many times to get to 1000? No, we don't want to do that. So we really need the formula. We need the explicit formula for this particular sequence. So let's start with the common difference. If we have terms that are in sequence, I find the common difference by going 7 minus 3 or 11 minus 7, right? That's how we find the common difference. So in this case, the common difference 7 minus 3 is 4, so I add 4 every time. Right? That's what we do if they're in sequence. If they're not in sequence, we have a little bit of a problem, but there's a cool little formula that you could use that would help you tremendously. Do you have to memorize it? No, there's other ways to get the common difference, but I think this is the easiest. So this little formula, what we do is we take the biggest, I want to say the biggest term number, the term that's farthest right, which is the 92. And we subtract the smaller term, the one that's farthest to the left. They don't necessarily have to be smaller or bigger. I'm talking about term numbers. So the 19th term minus the 11th term. And we write that over 19 minus 11. What that does is just does a cool little thing, and it helps us to, it's kind of like an averaging thing, but I know we're not averaging, but we're taking the difference between, and it makes sense, we're taking the difference between the values of the terms and the difference in the number of terms, and that's going to give us the common difference. So we do that and we get a 5. Alright, so we also need the first term to write our formula. So to find a sub 1, this is something that you could do. What I'm going to do is I'm going to take the 11th term, 52, and I'm going to subtract. So I have the 11th term and I want the 10th term. Excuse me, I want the first term. I have the 11th, I want the first term. So what do? Well, I take my common difference and I multiply it by the number of terms I want to get rid of, which is 10 of them. But I want to get down to the first one. So that's one way to find the first term, is by taking one of the term numbers, subtracting the common difference times however many terms we want to eliminate. In this case, we would get a 2. Now, what if I wanted to do the 19th term? If I wanted to use this formula for the 19th term, or this technique, I guess it's not a formula, it's a technique. If I wanted to use this technique to get to the first term and I have the 19th term, what would I put right here? 18, right? Minus 5 times 18, and it would still give me the 2. So that's just a technique that you can use to actually find any term number that you wanted. So let's write out our nth term. So it's the first term plus n minus 1 times the common difference. I'm going to go ahead and distribute and combine like terms just because. Do I have to? No, because my final answer isn't the nth term, right? It didn't ask me to find the nth term. That's just a tool on my way to find the 1000th term. But just for fun, let's go ahead and get it prettied up. So I have 5n minus 3 is basically what I'm dealing with. That's my formula for my nth term for this sequence. So I want to find my 1000th term, and that's going to be 5 times 1000 minus 3, which is going to be 49.97. So So my thousandth term is 4,997. Okay, how are we with that? We okay? All right. Let's go to our next problem. They're asking us to find the sum of the first 40 terms of the arithmetic sequence. Okay, so let's remember our little sum formula. I think this one's the easy one. We take the number of terms, we multiply the number of terms times the first term plus the last term over 2. Right? We're averaging. We're getting the average term and we're multiplying it by the number of terms. That's the way the summing formula works. So what do I need? Well, I know how many terms I have, but I don't know what the 40th term is. Could I get on my calculator and do 15 and I can do plus, you know, what do we just already decided what the common difference was, right? The common difference is 4 plus 4 plus 4 plus 4. Could I just keep hitting plus 4 on my calculator? Yes. That's not a really good idea. What if you miscount? And, you know, what if I give you the first million terms or something? I don't know. That might be fun. So what we need to do is actually write the nth term formula and find our term that we want. So a sub n is going to be the first term plus n minus 1 times the common difference. Now I'm just going to leave it like that. I'm just going to use it and plug in a 40 where the n is instead of like spending time to get the formula looking nice. I'm just going to use it. So a sub 40 equals 3 plus 40 minus 1 times 4, which is 159. So let's talk about the work that we need to show when we're doing this. Let's talk about the work that we need to show. So what do we need? We need to show, let's just kind of underline the things we need to show. We need to show this formula on this problem. And since I neglected to do this back here, what do we need to show here? We need to show this formula. Okay, you can do the second term in your head if you want to. I don't need to see that. But I need to see this formula, right? That's what I need to see, those formulas. And you can use your calculator for the other things. And then this. So I expect you to show me formulas, is what basically the work that you're required to show. The formulas and the answer. The formula and the answer. So let's go back to this problem, keep working it. So I have my sum, and it's my 40th partial sum. That number means something. I want you to use them. Use the sub numbers. It means the 40th partial sum. If I don't put a number there, who even knows what I'm doing? Right? It's the 40th partial sum. It's going to be equal to 40 times, and then my first term is 3 plus my last term is 159 over 2. Okay, we'll go back to what we're required to show. That formula. That's going to be, you know, we show the formulas. Then we find our 40th partial sum by using our calculator, and we get 3240. Okay, and of course we show the answer. All right. We okay? All right, last problem. How many terms of the arithmetic sequences 5, 7, 9 must be added to get 572? Okay, we don't know the term number. We don't know the last term. So to use this formula would be quite difficult, right? Would be quite difficult because I don't know n and I don't know a sub n. But now let's think about that other formula. What's really happened to that other formula? They took the a sub n and they just put in, let's put the other formula up here. A sub n equals a plus n minus 1 times d. So think about this being replaced with this. Think about that, and let's write this other formula up here. Let's see if we can see what's going on, and this is s sub n. Okay, do we see how they got this fancy formula? So the reason this formula is going to be very helpful to us is we know the first term and we don't know n, so we're down to one variable. It's a beautiful thing, right? It's great. Could you get there otherwise? Yeah, you'd have to do this and then that and so forth. You're going to get to this formula anyway. So let's use this formula and put the information in it that we have. We know the sum that we want is 572. N over 2 times 2a. Well, we know a, right? What is a? A is 5. So we know a. So 2 times 5 plus n minus 1. And we know the common difference, right? If it goes 5, 7, 9, what's the common difference? It's 2, right? So that way, now I have an equation to solve that only has one unknown, which is n. We all see that? So my job now is to, clean it up, solve for n, figure out what's going on. So let's do that. So 572 equals, so let's see, that's what, 10 plus 2n minus 2. N over 2, so what is that, 8 plus 2n. And then I'm going to multiply by n over 2. So that's what, 4n plus n squared. Do we see where this is going? Yes, we get to find factors of 572. Woo! Which is why you would have access to a calculator. I don't expect you to be able to do that in your head. I mean, some of you can. I know some of you can, but, I'm kind of taking care of those like me that would not be able to do that in my head. There's no way. It would take me forever to do that on paper, to try to find the factors of 572. So we factor it. And it actually turns out to be 26 and 22. So n is going to be negative 26, or n is going to be 22. Well, let's think about those numbers for a second. What do we know about n? N can't be negative. N is not possible to be negative. It has to be positive. So this is basically extraneous. I don't need that, right? It's n equals 22. Well, let's talk about the work on here. What do I need to see for you to get credit? What do I need to see? I need to see the formula. Okay? I need to see that. And of course, you can write as many steps as you want to. I'm just showing you the bare minimum that I need to see for you to get credit for the problem. I need to see the formula that you plugged into. I need to see what your quadratic is. And then, your factors. That's what I need. Okay? How are we on this? All right.